Hello all. Good Hello all. Good evening of you. Welcome to Unacademy. Today we will going to see our next topic, that is from the calculus. We will see in this topic directional derivatives and irrotational fields. Okay. In this session we will see how to find out the directional derivatives if the vector field f bar is given. Okay, we will see the different types of directional derivatives and how to find out the scalar potential phi when the vector field f bar is irrotational. So before going to start our actual topic, let me introduce myself. Myself Dhanashree Palasdeokar. I completed my MSc in Mathematics from Mumbai University, and I also having 13 plus years of teaching experience, and I mentored more than 10,000 plus students for the engineering. Before going to this, I will introduce how to install the Unacademy Learning app. क्या करना है, आपके मोबाइल पे प्ले स्टोर ऐप पे जाना है, प्ले स्टोर ऐप पे अनअकैडमी लर्निंग ऐप सर्च करना है, उसके बाद वो ऐप इंस्टॉल करना है. Then you have to manage your goal, that which goals you want to study, that you have to manage your. जैसे कि हम लोग अभी गेट एंड ईएसई के लिए पढ़ रहे हैं, तो आप गेट एंड ईएसई के लिए यहाँ पे अपना गोल मैनेज कर दो. उसके बाद अगर आप जो भी सब्सक्रिप्शन लेना चाहते हो, हर एक सब्सक्रिप्शन के अलग अलग फायदे हैं, जैसे कि प्लस सब्सक्रिप्शन है, फ्री कोर्सेज है, स्पेशल क्लासेस है, everything having the different benefits, so you can choose as per your requirement and then take a get subscription button, press the get subscription button icon, so you will get the Unacademy's app. And after that you have to study, you have to select your subscription plan, either it is for 12 months, 24 months, whatever you want to study, that you have to choose your subscription plan here. And then if you want to, सबसे बड़ी बात मैं यहाँ पे बताने जा रही हूँ, if you want a 10% discount on your subscription fees, then you can use my promo code, that is GSP, so you will get 10% discount on your subscription fees. And the next one is, अगर आप जो भी सब्सक्रिप्शन फीस आप पे करना चाहते हो, यू कैन पे इन एनी वन ऑफ बाय यूजिंग दिस मेथड, जो कि आपकी स्क्रीन पे दिखाई दे रही है, जैसे कि डेबिट कार्ड है, क्रेडिट कार्ड है, ईएमआई है, यूपीआई है, वैलेट्स है, नेट बैंकिंग है, whatever you can want, you can pay your subscription fee by using this. Now let's start our actual topic, that is directional derivative. Okay, what you mean by directional derivative? लास्ट लेक्चर हमने देखा है यहाँ पे कि हम लोग del phi, that is gradient of phi, or dot product of two vectors, how to find out the unit normal vector, so everything we have seen in the last lecture. अगर आपने नहीं देखा है तो आप यहाँ पे जाके वीडियो सर्च करके देख सकते हो, जिसमें आपके डॉट प्रोडक्ट, क्रॉस प्रोडक्ट और ग्रेडियंट, डाइवर्जेंस, कर्ल्स के जो भी डाउट्स है वो क्लियर हो जाएंगे. यहाँ पे हम लोग देख रहे हैं अभी डायरेक्शनल डेरिवेटिव्स. द डायरेक्शनल डेरिवेटिव ऑफ अ स्केलर पॉइंट फंक्शन. सी द मेन एक्चुअल डेफिनेशन ऑफ द डायरेक्शनल डेरिवेटिव्स. The directional derivative of a scalar point function phi of xyz is equal to c at point p of xyz in the direction of given vector a bar is given by directional derivative is equal to del phi at point P dot a cap. ये main definition है हमारे directional derivative की. ये point P, it means P of x y z, whatever point is given to you to find out the directional derivative for that function phi of x y z at the given point P. You can find out the directional derivative by using this formula. Directional derivative at point P is given by del phi at P dot a cap. What do you mean by del phi? It is grad phi, as we have seen earlier in that lecture, how to find out the del phi. What is your del? So we will take a quick recap of that lecture. So what is your del? Del is the I dabba by dabba x plus z dabba by dabba y plus k dabba by dabba z. That is your del operator. I dabba by dabba x plus z dabba by dabba y plus k dabba by dabba z. This is your del operator, directional derivatives. Now see, see to find out this del phi at p dot a cap. Okay, a cap is the unit normal vector and which can be calculated by using the formula a cap is equal to a bar upon mod of a bar. Now we know the suppose your vector a bar is equal to ai bar plus b a bar plus c k bar, then we can calculate mod of a bar is equal to square root of a square plus b square plus c square. So you can calculate mod of a bar by using the formula square root of a square plus b square plus c square. Okay. So this is your formula to calculate the mod of a bar, and a cap is given by a bar upon mod of a bar. Okay. So del phi at point P is dot a cap is the directional derivative. Now we will see directional derivatives of different types. Now the directional derivative of phi of xyz at point P of xyz in the direction of given vector a bar is equal to a1 I bar plus a2 a bar plus a3 k bar, then directional derivative is equal to del phi at point P dot a cap. Okay, so directional derivative of del phi at point P dot a cap. This is your directional derivative when the vector a bar is directly given to you. Your first point, when the vector a bar is directly given to you, how to find out the directional derivative? Now see, when the vector along the line PQ, where P is Q of x1, y1, z1 and Q of x2, y2, z2 are given, then a bar is equal to PQ bar, where PQ bar is equal to Q bar minus P bar. Okay. What do you mean by PQ bar? PQ bar is equal to A bar is equal to Q bar minus P bar. यहाँ पे डायरेक्टली वेक्टर A bar आपको दिया गया है, यहाँ पे वेक्टर डायरेक्टली A bar दिया नहीं है, but the points are given. You can find out that vector A bar is equal to PQ bar, where PQ bar is equal to Q bar minus P bar. Now tangent to the given vector. So what are the tangent to the given vector? Okay, tangent is nothing but the slope of the given vector. So see, x is equal to x of t, some function of t is given, y is equal to y of t, z is equal to z of t, and at t is equal to t0 some points, or this is given for some point t is equal to t0. Then as we know that in the last lecture we have seen what you mean by dr by dt. Dr by dt is the velocity vector. Okay, see r bar is our position vector, that is xi bar plus yj bar plus zk bar. We have seen already in the last lecture, that is r bar is equal to xi bar plus yj bar plus zk bar. Here zk bar. Then your position vector is your position vector, then your velocity vector is dr bar by dt, and here a bar is equal to dr bar by dt at t bar is equal to t0. Okay. So dr bar by dt is equal to at t is equal to t0. This is your tangent vector. Now P is where r bar is equal to x of t I bar plus y of t z bar plus z of t k bar. Now third point is given. See, there are four different types, five, six different types of directional derivatives we will find out here. First type is whenever the vector a bar is directly given to you. Second point is whenever the points are given, then find out the vector directional derivatives for that. So first of all, we have to find out vector for that 2 points. We can calculate that vector by using the formula a bar is equal to q bar minus p bar. Okay. Third one, the tangent to the given curve. Okay, the vector is given tangent to the given curve when x is equal to x of t, y is equal to y of t, and z is equal to z of t, at t is equal to t0, then your vector a bar is equal to dr bar by dt at t is equal to t0, where r bar is equal to x of t I bar plus y of t z bar plus z of t k bar. ये हो गया थर्ड पॉइंट. तब इससे हम लोग a बार निकालेंगे और डायरेक्शनल डेरिवेटिव फाइंड आउट करेंगे. नॉर्मल मतलब अभी डायरेक्टली वेक्टर ए बार भी दिया नहीं है, पॉइंट्स भी दिए नहीं है, और टैंजेंट के कंपोनेंट्स भी दिए नहीं है. तो हाउ टू फाइंड आउट दिस? नॉर्मल टू सरफेस साई ऑफ एक्स वाई जेड एट द पॉइंट क्यू ऑफ x2 y2 z2. तो पॉइंट आपको P दिया होगा, फाइंड आउट एट दैट पॉइंट, बट यहाँ पे आपको नॉर्मल टू द सरफेस साई ऑफ एक्स वाई जेड एट पॉइंट क्यू ऑफ x2 y2 z2 दिया. तो मतलब क्या है कि यहाँ पे हम लोग में नॉर्मल दिया हुआ है, तो हमें पता है कि अगर फाई इज द फंक्शन है, लास्ट लेक्चर में हमने देखा है अगर फाई इज द फंक्शन है तो डेल फाई उसका क्या होता है? नॉर्मल होता है. that will find out. अब हम लोग यहाँ पे normal vector find out करेंगे by using del psi. Okay, del psi at x y z. तो वहाँ पे हम लोग normal vector find out करेंगे del psi. So del psi calculate करने के बाद at that point x2 y2 z2, तो वो बन गया आपका a bar, vector a bar. Okay. So now I think you are all are clear. We will see when every type of example is in this lecture. So whenever the vector a bar is directly given, when the points are given, then how to find out the vector a bar. Third one, the tangent to the given curve. It means the components of the tangents are given, then find out the a bar, and after that find out the directional derivatives. And fourth point is that so normal to the surface psi. It means two surfaces are given, then find out the directional derivative for that given function vector field f bar. Okay. Now, fifth one, the case is fifth one. In this case, see equation of the line passing through the point x1, y1, z1 is given by. मतलब अगर equation of the line passing through the point x1, y1, z1 दिया हुआ है, right? A, B, C, x minus x1, y minus y1, z minus z1 upon यहाँ पे x, A, B, C, where A, B, C are the direction ratios of the line. Then a vector along this line is given by AI plus BJ plus CK. Directly you will get the vector A bar is equal to AI bar plus BJ bar plus CK bar. Okay, whenever the directional derivatives are given to you. So now see, sixth point is when the equation of a line equally inclined, making an equal angles with coordinate axis is given by. It means equation of an angle equally inclined is given, then your vector A bar, directly you can write vector A bar is equal to I bar plus A bar plus K bar. Okay. Now see, if you observe here, there are 6 different types of directional derivatives. We will see each type of one example. Example of each type here, how to find out the directional derivatives when the examples are given of that type. Whenever vector A bar is directly given, when points are given, then tangent components are given, then normal surface is given, then equation of line passing through the points x1, y1, z1 is given, and then lastly when the equation of a line equally inclined with making an angle equal angles with coordinate axis is given. Okay. Now, first example, find the directional derivative of phi is equal to x square yz plus 4xz square at the point 1 minus 2 minus 1 in the direction of the vector 2I bar minus j bar minus 2k bar. Okay, that we will see how to find out it. Now see, first of all for that we have to find out 2I bar minus j bar minus 2k bar. So directional derivatives, our formula क्या है हमारा, directional derivative is equal to del phi at point P dot a cap. Okay, del phi at point P dot a cap. यहाँ पे del phi क्या है, del phi, del it means first we will calculate del phi at point P, so we will call that this as equation 1. Okay, so del phi at point P, so first calculate del phi. We know that how to calculate the del phi, we already have seen in the last lecture how to calculate del phi. Del is I dabba by dabba x plus j dabba by dabba y plus k dabba by dabba z of phi. Phi is x square yz plus 4xz square. Okay, so del phi is equal to this. So del phi is equal to I into dabba by dabba x of this. So given gaya 2xyz I bar. Okay, now plus यहाँ पे 4z square. Here is also x. So plus 4z square I bar plus dabba by dabba y of this. So dabba by dabba y of this is x square z bar plus dabba by dabba z of this. So dabba by dabba z of this is x square y plus 2 into 4, that is 8xz k bar. Okay, so you will get this. Now we will calculate del phi at point 1 minus 2 1. So del phi at point 1 minus 2 1. We'll calculate first del phi. We'll write down here del phi but 2xyz plus 4z square 2xyz yz plus 4z square I bar plus x square z bar plus x square z bar plus x square y plus 8xz k bar okay, 2xyz here 2xyz plus 4z square I bar plus x square z bar plus x square y plus 8xz k bar. So del phi is equal to this. So you will get here del phi at point 1 minus 2 1 1 minus 2 minus 1 is equal to 1 minus 2 minus 1, put x is equal to 1, y is equal to minus 2. So 2 into 1 into minus 1 plus 4 into minus 1 square I bar, okay, plus 1 square into minus 1 z bar plus 1 square into minus 2 plus 8 into x is 1 into z, that is minus 1 k bar, okay. So which is equal to minus 2 minus 1, that is plus 2, 2 into 2 4 plus minus 1 square is so plus 4 plus is 8 I bar. Here you will getting 8 I bar minus here 1 square into minus 1 is minus z bar plus minus 2 into minus 8, so minus 10 k bar. ये बन गया हमारा del phi at 1 minus 2 minus 1. This is our del phi at 1 minus 2 minus 1. Okay. Now we will see 8 I bar minus z bar minus 10 k bar. Your del phi at point B. Now we will calculate. Your vector a bar is directly given. Your a bar is equal to 2 I bar minus a bar minus 2 k bar. 2 I bar minus a bar minus 2 k bar. Okay. Vector a cap is equal to, now we will calculate mod of a bar is equal to square root of 4 plus 1 plus 4 root 9, that is 3. Mod of a bar is equal to 3. Okay. So you will get vector a cap. A cap is equal to a bar upon mod of a bar. A bar is 2 I bar minus a bar minus 2 k bar upon 3. 2 I bar minus a bar minus 2 k bar upon 3. Okay. So directional derivative is equal to del phi at point P dot a cap. Okay. So del phi at point P is 8 I bar minus a bar minus 10 k bar. 8 I bar minus a bar minus 10 k bar dot a cap. Dot a cap, that is 2 I bar minus a bar minus 2 k bar upon, you know, we will take the dot product. We know that dot product with itself is 1 and with others is 0. So 8 into 2 I bar, 8 I bar dot 2 I bar, that is 16 minus minus here is plus 1 minus 10 into plus 20, get 47 by 3 the directional derivative for the given vector field F in surface phi is equal to x square yz plus 4xz square. Okay, I hope you are clear here. Whenever the vector field a bar is, whenever the vector a bar is directly given, then how to find out the directional derivatives for that given vector is? Now, we'll see the next example. See, in this example, we will find out the directional derivative of the function phi is equal to, the derivative phi is equal to, here, x square minus y square plus 2z square, okay, x square minus y square plus 2z square at the point p of 1, 2, 3 in the direction of pq where q is phi 0, okay, where q is phi 0, 4. So q is given, p is given. Directly vector a bar is not given. So what's our first job? We'll calculate the vector a bar and then calculate del phi at point p and then take the dot product with a cap. Okay. So here the second type of example where vector a bar is not given but the points are given. So here you will get vector a bar is equal to pq bar is equal to q bar minus p bar is equal to 504 minus 1, 2, 3. We get vector a bar is equal to 5 minus 1, that is 4, 0 minus 2 minus 2, 4 minus 3, 1. So 4 minus 2, 1 is the vector a bar. Directly you will get here vector a bar is equal to this. So we can calculate a cap also. So mod of, for that we required a cap, mod of a bar. So mod of a bar is equal to square root of 16 plus 4 plus 1, right? So you will get root of 21. Mod of a bar is root of 21. Now you can find out a cap is equal to a bar upon mod of a bar, right? So your a bar is 4i bar minus 2j bar plus k bar upon root of 21. This is your vector, unit normal vector a cap. Okay. Now we'll calculate del phi. Now your phi is equal to x square minus y square plus 2z square, x square minus y square plus 2z square. So your del phi is equal to, your del phi is equal to I dabba by dabba x plus z dabba by dabba y plus k dabba by dabba z of phi x square minus y square plus 2z square. Okay. So you will get I dabba by dabba x of this. So 2x I bar plus z dabba by dabba y of this. Okay. X square, here is your I bar, here only del operator. We will get here I bar is equal into 2 dabba by dabba x of 2x I bar plus dabba by dabba y of this. So it will gives you minus 5 plus dabba by dabba z of this 4z k bar. So this is your del phi. Now calculate del phi at point P. So at point P, P is given 1, 2, 3. Del phi at point 1, 2, 3. So x is equal to 1, 2 I bar. Y is equal to 2 plus 4z bar. Z is equal to 3 plus 12k bar. Okay. 2 I bar minus 4z bar plus 12k bar. This is the del phi at point P. Okay. Now we will calculate the directional derivative. Directional derivative is equal to del phi at point dot a cap. Okay, del phi at point P dot a cap. So 2 I bar minus 4z bar plus 12k bar. 2 I bar minus 4z bar plus 12k bar dot a cap है हमारा 4i bar minus 2z bar plus k bar 4i bar minus 2z bar plus k bar, right, upon root 21. Now take the dot product. So you will get 4 into 2, 8, minus 4 into minus 2, plus 8, 12 into 1, plus 12 upon root 21. Okay. So 12 plus 8, 20 plus 8, 28 by root 21 is the directional derivative of the given vector field or given function phi. So the directional derivative is equal to 28 by root of 20. Right? This is your directional derivative for the given vector field f. Given scalar function phi. Not vector field, sorry. The given scalar derivative of the given scalar function phi. We will see the third point. In these first two examples we have seen whenever the vector a bar is directly given. Second example we have seen when the points of that vector are given. Now see, it is the third type where the tangent components are given. Okay, x, y, z is given. So how to find out the directional derivative for this function? Now see, first we will calculate here a bar. So what is our a bar? A bar is equal to dr bar by dt, right? But for that dr bar by dt we required r bar. So how we can calculate r bar? Simply we will calculate r bar first. R bar is equal to xi bar plus yj bar plus zk bar. R bar is equal to xi bar plus yj bar plus zk bar. So here you will get r bar is equal to e raised to t cos t, e raised to t cos t I bar plus e raised to t sin t j bar plus e raised to t k bar, right? R bar is equal to e raised to t cos t I bar plus e raised to t sin t j bar plus e raised to t k bar. Now this is your vector R bar. Now how we can calculate the vector A bar? A bar is nothing but the dr bar by dt at the given point t is equal to t0, but t0 is here. Okay. So we will calculate first dr bar by dt. So you will calculate dr bar by dt. Your r bar is equal to here. Vector r bar is given e raised to t cos t I bar plus e raised to t sin t j bar, e raised to t sin t j bar plus e raised to t k bar plus e raised to t k bar. Okay, this is your vector r bar. Now we will calculate a bar dr bar by dt, dr bar by dt, which is equal to, now see here e raised to t into cos t. So we will use uv rule to find out the or multiplication of the derivatives rule. So you will get e raised to t. So first derivative of second, that is minus sin t plus second into derivative of first. Okay. Hope you are clear here. E raised to minus e raised to sin t plus cos t into e raised to plus same here e raised to t first into derivative of second plus second into derivative of first of j bar plus derivative of e raised to t with respect to t is e raised to k bar. Your dr bar by dt. What is your vector a bar? A bar is equal to dr bar by dt at t is equal to 0. Okay, so put t is equal to 0. Sin 0, 0. So this term becomes 0. Cos 0, 1. E raised to 0 is 1. So here is 1. So you will get I bar only. Plus, now put t is equal to 0. So e raised to 0 is 1 and cos 0 is 1. So you will get 1 plus sin 0, 0. So ultimately this terms becomes 0. So you will get here 1 only. 1 into z bar, so z bar plus e raised to 0. So here e raised to 0 is 1 So you will get e raised to 0. It means the k bar. E raised to 0 is k bar. So a bar is equal to dr bar by dt. At t is equal to 0. So I bar plus a bar plus k bar. Your vector a bar. Now we will calculate del phi. Okay, so what is phi? Phi is given 4xz cube minus 3x square y square z minus 3x square y square z. Okay, and the point P is given 2 minus 1 2. Point P is 2 minus 1 2. So calculate first del phi. Okay, so how to calculate del phi? Del phi is equal to I dabba by dabba x plus z dabba by dabba y plus k dabba by dabba z of phi. Phi is 4xz cube minus 3x square y square z. Okay. So which is equal to I into dabba by dabba x of this. So 4z cube minus 6xy square z I bar plus dabba by dabba y of this. So dabba by dabba y of this, you will get 2 into this 3. So minus 6x square y z bar. Right here, directly minus sign out of that. This of x in the calculation. Okay. Minus of 6x square y z bar plus dabba by dabba z of this. So you will get 12x z square minus 3x square y square k bar. Okay. So del phi at point P 2 minus 1 2 is equal to, so what is our 2 x z is equal to, what is our z? Z is equal to 2. So 2 cube is 8. 8 into 4 32 minus your x is equal to 2. 6 into 2 12 minus 1 square is 1. So 12 into 2 20. 22 minus 24i. Now you will get next point is, that is minus x is equal to 2. So 2 square 4. 4 into 6, that is 24 into minus 1 minus 24 minus plus 24 into 2 48 plus 48. You will get it here is plus 48 plus 48 z bar. That's 32 minus 24, so 8 I bar plus 48 z bar plus x is equal to 2. 24 into 4 96. 96 minus 2 square is 4. 3 into 4 12. 12 into minus, so 96 minus 12, that is 80. Get 88. I hope you are clear here how to calculate the del phi at point P is 8 I bar plus 48 z bar plus 84 k bar. Okay, this is your del phi. We will calculate directional derivative. Directional derivative is equal to del phi at point P dot a cap. So everything we have ready with us. So here del phi at point P is 8 I bar plus 8 I bar plus 48 z bar plus 84 k bar plus 84 k bar dot a cap. So what is our a cap? A cap is, this is our a bar. We'll calculate the a cap. So a cap is equal to a bar upon mod of a bar. So a bar is I bar plus a bar plus k bar upon mod of a bar is root of 1 plus 1 plus 1. So your a cap is I bar plus a bar plus k bar upon root 3. Okay. That we will write here. A cap is equal to I bar plus a bar plus k bar upon root 3. Okay. So dot product is equal to 8 into 1, 8 plus 48 plus 84 upon root 3. Okay. 48 plus 8 plus 84 by root 3. So you will get here 140 by root 8. You will get 140 by root 3 is the directional derivative for the given function phi. Okay. When the tangent components are given, then we will calculate vector a bar and how to find out the directional derivative. Here I think third type is clear here. Now we will see the fourth type. Find the directional derivative of phi equal to x square y plus y square z plus z square x square y plus y square z plus z square x. Then at the point 2, 2, 2 in the direction of normal to the surface 4x square y plus 2z square is equal to t at the point 2 at the point 2 minus 1 3. यहाँ पे हम लोग को क्या करना है डायरेक्शनल डेरिवेटिव दिया हुआ है फाइंड आउट करना है फॉर द नॉर्मल फंक्शन नॉर्मल सरफेस दिया हुआ है. So for that vector a bar is not given directly. So first of all we will calculate the vector a bar. तो अभी वेक्टर a bar कैसे कैलकुलेट करेंगे जो भी डेल ये जो वेक्टर दिया हुआ है हमें उसको हम लोग डेल साई बोलेंगे वेक्टर और फाइंड आउट करेंगे. तो फाइंड द डायरेक्शनल डेरिवेटिव ऑफ phi in the direction of normal to the surface this. Okay, so p is given and p for this psi is this and p for this phi is this 2 2 2. Okay, so first we will calculate del phi at p. So del phi is equal to I dabba by dabba x plus z dabba by dabba y plus k dabba by dabba z. I dabba by dabba x plus z dabba by dabba y plus k dabba by dabba z of phi x square y plus y square z plus z square x. Okay. So I into dabba by dabba x of this. So you will get 2x y plus z square I bar plus dabba by dabba y of this. So you will get x square plus 2yz z bar plus k into dabba by dabba z of this. You will get y square plus 2zx k bar. Hope you are clear here up to this step. So 2xy plus z square I bar plus x square plus 2yz z bar plus y square plus 2zx k bar. Okay. Now this is your del phi. Now we will calculate del phi at point 2, 2, 2. Okay. So immediately we can calculate here del phi at point 2, 2, 2. So x is equal to 2, y is equal to 2. 2 into 2 into 2 is 8. 8 plus 4, 12 I bar. Here you will get 12 I bar plus x square is 2, 2 square is 4, 4 plus 2 into 2 into 2. So again 12 I bar plus y square is 2. Y is 2, so 2 square is 4, 4 plus 2 into 2 into 2. Again 8, so 12 k bar. So this is your del phi at point P. Okay. Now we will calculate vector a bar, but vector a bar is nothing but the normal to the surface phi. So vector a bar is normal to given surface, normal to given surface psi. Okay. A bar is nothing but the normal to the given surface psi. So a bar is equal to del psi. Okay. A bar is equal to del psi. So you will get a bar is equal to I dabba by dabba x plus z dabba by dabba y plus k dabba by dabba z of psi. What is our psi? Psi is 4x square y plus 2z square is equal to 2. It means 4x square y plus 2z square minus 2. 4x square y plus 2z square minus 2. Okay. This is our psi. We will calculate the dabba by dabba x of this. So we will get 8xy I bar plus dabba by dabba y of this. So you will get 4x square z bar plus dabba by dabba z of this 4z k bar. Okay, so this is your a bar. A bar is equal to x by 8xy I bar plus 4x square z bar plus 4z k bar. Okay, this is your vector a bar. Now we will calculate a cap. A cap is equal to a bar upon mod of a bar. So a bar is 8xy I bar plus 4x square z bar plus 4z k bar upon mod of a bar. Mod of a bar is square root of, so mod of a bar, now this is only a bar but we didn't find out at point. We'll first calculate at point a bar. A bar at point given 2 minus 1 3. 2 minus 1 3. Your a bar as 2 minus 1 3 is 16 minus 16 I bar plus square is 4. 4 means a bar plus z is 3. 12k is your a bar. We'll calculate mod of a bar. Mod of a bar is equal to root of minus 16 square. So root of minus 16 square is, we'll get 256 plus root of 16 plus 40. It gives you mod of a bar is equal to root of 656. Okay. Your mod of a bar. Calculate a cap is equal to a bar upon mod of a bar. Your a bar is minus 16 I bar plus 16 a bar plus 12 k bar upon mod of a bar. Mod of a bar is root of 6. Mod of a bar is root of 6. Cap is equal to this. Okay. Now we will calculate the directional. Directional derivative is equal to del phi at point P dot a cap. Del phi at point P we already calculated, that is 12 I bar plus 12 Z bar plus 12 K bar. Here you will get 12 I bar plus 12 Z bar plus 12 K bar, okay, upon 12 I bar plus 12 Z bar plus 12 K bar, 12 Z bar plus 12 K bar dot A cap is 16 I bar plus 16 Z bar plus 12 K bar upon root of 656. Okay. So 12 into minus 16 I bar dot I bar, so you will get directional derivative is equal to, just do the calculation, it's a very simple calculation, 16 into 12 plus 16 into 12 plus 12 into 12. Okay. That we will give you 144 upon root of 656. So 144 upon root of 656, that is your, we can take 4 common, so get 36 upon the directional derivative for the given path. Next example. Now here where the directional, find the directional derivative of phi where phi is equal to xy square plus yz cube at the point 2 minus 1 1 along the line of x minus 2 is equal to y plus 1 is equal to z minus 1 along the line 2 of x minus 2 plus y plus is equal to y plus 1 is equal to z minus 1. Now if we observe the directional derivative of this function phi is equal to at the point, so line is given, so we will see the fifth point here. The fifth point, equation of the line passing through the point x1 y1 z1 is given by, so we will convert that line in the standard form. Okay, so x minus x1 upon a, y minus y1 upon b, z minus z1 upon, we will convert that line in this form, so you will get here a of x into bracket x minus 2 equal to y plus 1 upon z equal to z minus 1. So you will get the directional derivative of phi at, here phi is equal to, first we will calculate phi, del phi. So del phi is equal to I dabba by dabba x plus j dabba by dabba y k dabba by dabba z of phi xy square plus yz cube. So dabba I del phi is equal to I dabba by dabba x plus j dabba by dabba y dabba by dabba z of phi, okay, which is equal to I into dabba by dabba x of this get y square I bar plus dabba by dabba y of this, so 2xy plus z cube z bar plus dabba by dabba z of this will get 5z square k bar. Calculate del phi at point P. P is given minus 1 equal to minus 1 square, that is I bar, plus 2 into x into y. So 2 into 2 to y, 4 minus 4 plus 1. You get minus 3z, right? Plus here you will get 3 into minus 1 minus 3 plus minus 3 k bar minus 3 k bar. Here del phi at 2 minus 1 1, so I bar minus 3 z bar minus k bar. So you will get del phi at point this point. So we'll calculate first a bar. What is our a bar? A bar is, so equation of the line given 2 into x minus 2 2 into x minus 2 is equal to y plus 1 is equal to z minus 1, okay, equal to z minus 1. So ultimately your equation will be x minus 2 by 1 equal to y plus 1 by 2 equal to z minus 1 by, so you, therefore vector a bar along this line. So our standard form is x minus x1 upon a is equal to y minus y1 upon p is equal to z minus z1 upon p. So vector along this line is ai bar plus bj bar plus k bar, right? So here a is equal to 1, b is equal to 2, c is equal to 2. So your vector a bar is equal to, this case I bar plus 2j bar plus 2k bar. Vector a bar is equal to I bar plus 2j bar plus 2k bar. This is your vector. Find the directional derivative of phi. Find the directional derivative of phi is equal to 4xz cube minus 3x square y square z at the point 2 minus 1 1 along the line equally inclined with coordinate axis. Okay. Find the directional derivative of phi equal to 4xz cube minus 3x square y square z at the point minus 1 1 along the line inclined with the coordinate axis. Very simple example. See, along the line equal inclined with coordinate axis. So your vector a bar is equal to I bar plus j bar plus k bar. Okay. So very simple. First we will calculate del phi. Now phi is given. So you can calculate del phi. So what is our del phi? Del phi is equal to I dabba by dabba x plus z dabba by dabba y plus k dabba by dabba z of 4x z cube minus 3x square y square z. Del phi is I dabba by dabba x of this. So you will get 4z cube minus 6xy square z I bar plus dabba by dabba y of this. So dabba by dabba y is minus 6 x square yz z bar plus. Now I hope you are clear here how to find out the del phi. So k into dabba by dabba z of this. So k into dabba by dabba z of this you will get 12, writing in the next line. So 12 x z square minus 3x square y square k bar. Okay. So this is your del phi. Now we will calculate del phi at point 2 minus 1 1. So del phi at point 2 minus 1 1. First we will calculate del phi at point 2 minus 1 1. So you will get, so put z is equal to 1. So 4 into 1 4. 4 minus 6 into 2 12 to 1 minus 12 I bar. So you will get minus 8, right? Minus 8 I bar. Directly here z cube. 4z cube is 4 6 2 minus 1 minus 8. Your y square is equal to 1. 12 plus 4 minus 8 I bar 6 into 2 12 24 plus 20 z bar 24 into 6 into 4 to 2 square 4 24 minus 1 minus get your is 0 y is y get minus 6 into 4 plus 12 into 2 24 minus 4 into 3 12 and 4 minus 12 so plus 12 k bar. So del phi at 2 minus 1 1 is equal to minus 8 I bar plus 24 z bar plus 12 k bar. K bar is equal to, as the lines equally inclined with coordinate axis, therefore as line equally inclined with coordinate axis, equally inclined with coordinate axis. So vector a bar is equal to I bar plus b bar. Your a cap is equal to a bar upon mod of a bar, which is I bar plus b bar up root of 1 plus 1 plus 1, that is 3. Here a bar. Can calculate directional derivative. Okay. Directional derivative is equal to del phi at point E dot a cap. So your del phi is minus 8 I bar plus 24 Z bar plus 8 I bar plus 24 Z bar minus plus 12 K bar 12 K bar dot a cap. So what is our a cap? A cap is I bar plus Z bar plus K bar upon root. The dot product of this is minus 8 plus 20 plus 12 upon minus 8 plus 24 plus 12 upon get 36 minus 8. 6 minus 8 28 by root. So 28 by root the directional derivative for the verifies. Next point, which is very important, solenoidal and irrotational vector field. Okay, so solenoidal term एकदम simple है. So solenoidal and irrotational vector field. A vector field F bar is said to be solenoidal if del dot F bar, that is divergence of F bar, is equal to 0. हमने कल पढ़ा है. What do you mean by divergence of F bar? Okay, that is del dot F bar. The vector field F bar is solenoidal if del dot F bar, that is divergence of F bar, is equal to 0. Second, a vector field F bar is said to be irrotational. Vector field F bar is said to be irrotational if del cross F bar, that is curl of F bar, is equal to 0. In this case, there exists a scalar potential phi such that F bar is equal to del phi. अगर वो फील्ड वेक्टर फील्ड F bar irrotational आ गया तभी इसको स्केलर पोटेंशियल Fi मिलेगा, that is F bar is equal to del phi. If F bar is irrotational, on LHS will be total differential of some function on integrating on both sides, क्योंकि ये exact function हो जाएगा हमारा. हम लोग यहाँ पे इंटीग्रेटिंग रूल अप्लाई करेंगे. इंटीग्रल ऑफ f1 of xyz dx, integral of f1 of xyz dx plus integral keeping y and z constant plus integral of z keeping z constant terms of f2 free from x dy plus integral of terms of f3 free from x and y dz plus constant of integration c is equal to phi, because f bar dot dr bar is equal to del phi dot dr bar, so you will get phi only. Okay, so we will use this property and find out the scalar potential function phi. Okay. So first example is the vector field y sin z minus sin x I bar plus x sin z plus 2yz z bar plus xy cos z plus y square k bar are irrotational. Is the given vector field y sin z plus minus sin x I bar plus x sin z plus 2yz z bar plus xy cos z plus y square k bar irrotational? If so, find the scalar potential phi. Now irrotational is also called as the conservative. Okay? Many times the word is given that conservative instead of irrotational. If the vector field F bar is conservative, it means it is irrotational. If so, find the scalar potential phi. हमें irrotational check करना है. So what you mean by irrotational? We will see. Irrotational, it means if del cross F bar is equal to 0. So we will calculate or curl of F bar is equal to 0. In the previous lecture, we have already seen how to calculate the curl of vector field F bar. Okay. Now see, we will find out here curl of F bar. The curl of F bar, it means del cross F bar is equal to here I, Z, K, I bar, Z bar, K bar. Here dabba by dabba x, dabba by dabba y, dabba by dabba z of F1 I bar. So F1 है y sin z minus sin x, where yz and xy cos z plus y square. So you will get I bar into bracket dabba by dabba y of this. So dabba by dabba y of this, it means you will get x cos z plus 2y. X cos z plus 2y minus what we will do, we'll calculate this del cross f bar here. So minus here dabba by dabba z of this. So dabba by z of this x cos z plus 2y. Okay. Minus z bar into bracket minus z bar into bracket dabba by dabba x of this. So you will get y cos z minus dabba by dabba z of this. You will get here y cos z again. Value of this is 0 plus k bar into bracket dabba by dabba x of this sin z minus dabba by dabba y of this, that is sin z. If you see here x cos z plus 2y minus x cos z plus 2y, it becomes 0. Y cos z minus y cos z is again 0. Sin z minus sin z is equal to 0. So del cross f bar is equal to 0. Okay. So you are getting del cross f bar is equal to 0. As del cross f bar is 0, which implies f bar is irrotational. Shows that f bar is irrotational. And we know that as f bar is irrotational, then as f bar is irrotational, then we will see that there exists a scalar potential phi. See here. If f bar is irrotational, then there exists a scalar potential phi. हमें scalar potential phi कैसे निकालना है? Okay, we will see here f bar dot dr bar. There exists a scalar potential phi. As f bar is irrotational, there exists a scalar potential phi such that f bar is equal to del phi. Okay, such that f bar is equal to del phi. So you will get f bar dot dr bar is equal to del phi dot dr bar. Okay, so f bar dot dr bar is equal to del phi dot dr bar. So you will get integral of f bar dot dr bar is equal to phi. We will integrate this integral of f bar dot dr bar. So you will get integration of this is, so first here f bar, I am writing f bar is here, bar is y sin z sin z minus sin x I bar plus x sin z plus 2yz z bar plus x sin z plus 2yz z bar plus xy cos z plus y square k bar plus xy cos z plus y square k bar. Okay, y cos z plus y square k bar. Now, this is your f bar. F bar is equal to this. Now, you observe here f bar is equal to your f bar is this. Now integrating with f bar with respect to r bar. Okay, so you will get dx, dy and z. Dot product, you will get dx f bar is equal to f1 dx plus f2 dy plus f3 equal to, okay, so y sin z, so you will get f1 of dx, keep y and z constant, y sin z minus sin x dx, keeping yz constant, y z constant. Okay. So once you get keep y and z constant here, plus second one, integral of terms of f2 which are free from x. तो ऐसी कौन सी टर्म है जिसमें x की टर्म नहीं है? तो 2yz होगी. So 2yz by keeping z constant, keeping z constant. Okay. Plus third one, terms of f3 which are free from x and y. तो ऐसी कौन सी टर्म है जो terms of f3 which are free from y है? x and y एक भी टर्म नहीं है. Integral of 0 to is equal to integral of y, that is plus constant of integration is equal to pi. Get integral of this y sin z, writing here again integral of y sin z minus sin x dx plus integral of 2yz dy plus integral of 2yz plus integral of 0 dz plus c equal to 5. So keeping yz constant, z constant, okay, integrating this with respect to x. So keeping y and z constant, get x y sin, okay, minus integration of sin x is here. We'll get integration of minus sin x is right plus यहाँ पे बन जाएगा x y sin z plus cos x. Integral of 2yz, keeping z constant. Integration of 2y is 2y square by 2 plus integral of dz 0z. There is no term which are free from x and 0 plus c is equal to 5. तो आपका फाइनल आंसर होगा x y sin plus cos x plus 2 to cancel out plus z y square plus c equal to 5. Your scalar potential phi in the given vector field F bar is irrotation. Okay. Once again, so we find out here scalar potential phi when the given vector field F bar is irrotational. So first of all, irrotational, how to calculate the irrotational? Taking the cross product of del with F bar. So I is a k double by double x double by double y double by double z of y sin z minus sin x sin z plus 2yz, xy cos z plus y square. So taking cross product of it, and you will get the cross product is 0, so which implies del cross f bar is equal to 0, which implies f bar is irrotational. And as f bar is irrotational, there exists scalar potential phi such that f bar is equal to del phi, and f bar dot dr bar is equal to del phi dot dr bar. Okay. So integral of f bar dot dr bar is equal to phi, which implies f bar is equal to y sin z minus sin xi bar plus x sin z plus 2yz z bar plus xy cos z plus y square k bar. Okay. Now integrating this with respect to the, ये हमारा सही फॉर्मूला है एग्जैक्ट डिफरेंशियल इक्वेशन का. तो हम लोग यहाँ पे इंटीग्रेटिंग कीपिंग y and z constant, इंटीग्रल ऑफ f1 dx plus terms of f2 which are free from x. यहाँ पे the terms of f2 which are free from x only एक ही टर्म है यहाँ पे 2yz जिसमें x नहीं है, so which is free from x. So integral of 2yz dy keeping z constant plus integral of terms of f3 which are free from x and y. So 0 terms है. So integral of 0 dz plus c is equal to 5. So this is your scalar potential phi. Here after integrating you will get y sin z plus cos x plus zy square plus c equal to 5. See the next example. Show that the vector field F bar is irrotational and also find its scalar potential phi. So we will show that this is a scalar vector field F bar is irrotational. So for that we will consider del cross F bar. So what is our del cross F bar? I, Z, K, dabba by dabba x, dabba by dabba y, dabba by dabba z of F bar y square cos x plus z square 2y sin x 2xz. So here we will get del cross F bar is equal to I into bracket dabba by dabba y of this 0 minus dabba by dabba z of this 0 minus z into dabba by dabba x of this that is 2z minus dabba by dabba z of this that is 2z plus k into dabba by dabba x of this that is 2y sorry 2y cos x minus dabba by dabba y of this 2y cos x. So if you observe 0 0 0, so del cross F bar is equal to 0. So as del cross F bar is equal to 0, as del cross F bar is equal to 0, which implies vector field F bar is vector field F bar is irrotational. Vector field F bar is irrotational. As vector field F bar is irrotational, what did it get? There exists a scalar potential phi. There exists a scalar potential there exists a scalar potential phi. Now, once there exists a scalar potential phi, we can calculate here del dot F bar is equal del integral of F bar dot dr bar is equal to del phi dot dr bar. Okay, so we will get the integral of F bar dot dr bar is phi. So we will integrate this F bar dot dr bar. Your F bar is given integral of F bar f1 dx integral of f1 dx yz constant plus integral of terms of f2 which are free from x which are free from x dy z constant plus integral of terms of f3 which are free from x and y dz plus c equal to 5. Applying the same way, here we can write integral of yz terms of f1. Here f1 is y square cos x plus z square, y square cos x plus z square dx, y square cos x plus z square dx plus, here you will get secondly the terms of f3, the terms of f2 which are free from x is 2y sin x. Get directly here integral of 2y sin x, but here is not any term which is free from x because sin x is present there. We will get 0 dy z constant plus integral of f3 which are free from x and y. There is no any term again, so it will gives you again 0 z plus c 1. The integration of this keeping y and z constant. Integral of cos x is sin x y square sin plus z square keeping z constant. Derivative of this integration of this constant is z square x. Okay. Get here z square x y square cos x plus z square x. Sin x plus z square x plus integral of this is 0 plus 0 plus c phi. We will get the scalar potential phi as y square sin x plus z square x plus c is equal to phi. Your scalar potential phi. If you observe here, we have seen how to find out the scalar potential phi when the vector field f bar is given. Now, one by one, we will take you what we are learning in the lecture. Directional derivatives. What is the definition of a directional derivatives? Directional derivative is the scalar point function phi of xyz at c at the point p of xyz in the direction of given vector a bar and is given by directional derivative is equal to del phi at point p dot a cap, where a cap is equal to a bar upon mod of a bar. Okay. Now this, see, first one, types of directional derivatives. So directional derivative of phi of xyz at the point p of xyz in the direction of, first one, given vector a bar is equal to a1 I bar plus a2 z bar plus a3 k bar, and directional derivative is equal to del phi at point p dot a cap vector along the line pq, where p of x1 y1 z1 and q of x2 y2 z2, where a bar is equal to pq bar, where q bar minus p bar, and tangent to the curve. So x is equal to x of t, y is equal to y of t, z is equal to z of t at t is equal to t0. Here vector a bar is equal to dr bar by dt at t is equal to t0. Where r bar is equal to x of t I bar plus y of t z bar plus z of t k bar. So normal, fourth one, it is normal to the surface say psi of xyz. Normal to the surface say psi of xyz at point q of x2 y2 z2. Okay, whenever the two surface is given and only one point is given, so how to find out the directional derivative. So equation of a line passing through the point x1 y1 z1 is given by x minus x1 by a is equal to y minus y1 by b, z minus z1 by c, where a, b, c are the direction ratios of the line. Then a vector along this line is given by ai bar plus bj bar plus ck bar. Then equation of the line inclined making an angle equal angles with the coordinate axis given by x upon 1 is equal to y upon 1 is equal to z upon 1. Hence vector along this line is a I bar plus a bar plus k bar. Okay. So first example, this is the example where the vector a bar is directly given. Then how to find out the directional derivatives. Second one, when the vector a bar is directly given, points p and q are given, then how to find out the vector a bar and then find out the directional derivative. Now in this point where the vector a bar is not directly given, we will find out that by using a bar is equal to dr bar by dt tangent vector. This is your vector a bar here. Now the example number 4, where the directional derivative of phi is equal to x square y plus y square z plus z square x, then 2 2 2 at the point 2 2 2 in the direction of the normal to the surface 4x square y plus z, 2 z square is equal to 2 at the point 2 minus 1 3. Okay, this is your del phi. Now a bar is given, a cap is given. No, fifth one, whenever the function phi is given and then along the line is given. So we will convert it into standard equation of a line, that is x minus x1 upon a plus is equal to y minus y1 upon b is equal to z minus z1 upon c. As the direction equals. So the vector along this line is ai plus bj plus ck. So here a is equal to 1 to 1, b is equal to 2, c is equal to 2. So you will get vector a bar is equal to this. short. Find sixth one. Find the directional derivative of phi is equal to 4x z cube minus 3x square y square z at the point 2 minus 1 1 along the line equally inclined with the coordinate axis. अगर इक्वली इंक्लाइंड है तो डायरेक्टली हम लोग एक वेक्टर ए बार लिखेंगे. ए बार इज इक्वल टू आई बार प्लस के बार एंड डेल फाई डायरेक्शनल डेरिवेटिव कैलकुलेट करेंगे. डेल फाई एट पॉइंट पी डॉट ए कैप. नाउ the solenoidal and irrotational vector field. A vector field F bar is said to be solenoidal if del dot F bar is equal to, that is divergence of F bar is equal to 0. And a vector field F bar is said to be irrotational if del cross F bar, that is curl of F bar is equal to 0. In this case, there exists a scalar potential phi such that F bar is equal to del phi. And if F bar is irrotational on LHS, will be the total differential of the sum function on integrating on both sides, will get, because this is the exact differential equation, so you will get the exact equation. So you will get integral of f1 dx keeping y and z constant plus integral of terms of f2 which are free from x into dy plus terms of f3 which are free from x and y into dz plus c equal to 5. So this is your solenoidal and irrotational vector field, and the vector field F bar is given. Okay, so here we will find out how to find out the scalar potential irrotational, and if so it is scalar potential phi. Okay, I hope you are clear here how to find out the scalar potential of the given function. The function phi is given. Okay, now in the next lecture, we will see the properties of del. Okay, all the properties of del, that is del dot f bar, del dot r bar, del dot a bar cross b bar, del dot a bar cross b bar, del dot a bar dot r bar. Okay, and the questions on depending on that, which is very useful. And the properties are very important to solve the identity. Any identity we can solve by using. So we will see this in the next lecture. I will be coming in the same time tomorrow at 4 p.m. with the properties of that. Much keep watching. If you like my videos, please keep watching and do like, share and subscribe. Thank you.